first part, I guess. I told the joke already, so you can't hear it on the recording. But anyway, Mark is going to start and tell us all about the iFarm and GlueX environment. So, anybody sounds.
Okay, so on the one hand, this talk, I see some familiar faces from the last time we went through this. So on the one hand, it's pretty much the same talk as last time. So you can read your email. On the other hand, I went through it and I had to make a change almost on every page. So some of the details have changed. But back on the first hand, if I change the details on the slide, you're not going to notice it. You're still going to be bored, right? So let's just go. Okay, so really said this. Okay, terminology, various shells that are allowed, environment setup, and depending on the role, the use case that you occupy, a little bit about data and computing resources, and then a bunch of links on where to get help. So terminology, actually this is the one slide that didn't get changed. So I'm going to go, okay, at the risk of insulting your intelligence. Reconstruction. Reconstruction we talk about as taking the raw data, which is an EVIO form, and transforming it into, particles, okay, 4 vectors, energies, momenta, things like that, positions. Simulation or Monte Carlo you'll hear about. Make-believe events, and there's a whole technology that goes with this. Generation refers to the creation of the particles at the reaction point. Detector simulation, these are terms. You follow the particles through the make-believe detector, you create the hits, you have the particles interact with the material that it encounters as it passes through the detector according to the known laws of physics, does the things that physics says it should do in the simulation, and you create fake hits in this fake detector. And then smearing, this is a little bit of non-standard terminology, but not so non-standard. We do this in 2 separate steps. We create the hits in the detector with the true, say, energy deposited in a particular detector element. But then when we actually read out, of course, there's measurement error, and that's introduced in this smearing step. So, and then the other thing we talk about is analysis. And here we're taking these particles that come out of the reconstruction or the simulation. Remember, these are just 2 sources for what should be data which is indistinguishable from one realm or the other. In principle, we hope, cross your fingers. Transform them into physics-related quantities, and these particles you can access them in so-called rest files, okay, which is really the output of the reconstruction, and we also create root trees. So you can access it at both levels to do your analysis. The rest files are, our DST format, our compact format. The raw hits from the detector are gone from the rest files. Root trees are even further compacted and put into a form which is, of course, compatible with reading with the root program. Okay, so just so that those distinctions are clear. Okay, we support 2 shells. So these are the programs that you type into on the command line in your terminal. TCSH, which is a form of the C shell, and bash, which is a form of the born shell, thus the born again shell. A common convention that you'll see in scripts, although it's not uniformly followed everywhere and universally followed everywhere, and always is this .sh subscript for bash and .csh for TCSH. And in this talk, I'm going to use the bash form of all the commands that I talk about. Okay. Okay, so the beginner scenario. So in this scenario, you just want to run the software. It's already been compiled and linked, and it's ready to go. It's sitting there on a disk for you. You don't want to touch anything, change any lines of code at all, but you want to just configure it to do what it is that you want to do. Okay, so the recommendation now, this is different from last year, is that you put the following line in your profile file for Bash. So .profile, or in your .cshrc file if you're using the TC shell. Okay, and then you source. This is also, I'm going to be JLab specific. A lot of these scripts have JLab in the names because they are, in fact, JLab specific. They assume the directory structure that we have here at the lab. There are ways to reproduce a lot of this on some random computer, but I won't talk about any of that. I'll assume JLab for this talk. Okay, so you source this file. So boot implies that you're starting from scratch with nothing. Okay, and once you source this file, you define the command gxm for GlueX environment, and to invoke the command, you type gxm. Hey. And that gives you an environment. That gives this step gives you an environment with default versions of the software. This step doesn't give you anything except for this command. Okay, so if you put this in your profile or your .cshrc, it executes very quickly. Okay, and so since it's being done for every shell that you launch, it behooves you to have something that's economical. This is a little bit more heavyweight because the environment's a little bit complicated, and so this takes some time. So it's recommended that you not put this in your .profile. I mean, put the gxm command itself in your profile, although you can. Nothing prevents you from doing that. If you want to use another version rather than default versions of the software, maybe we have these collections of versions of the various components, which I will show on the next slide or one after that. Then you can name the version XML file. Again, I'll show you what that is in a second. This is a typo. This should not be there, that source. You just say gxenv with the name of the XML file. So I'll have to fix that. No source. No source. That was the leftover from the modifications of last year, obviously. Okay, so there's that. And then this environment variable dist, okay, is defined by this boot script. So that's available to you right away. So you don't have to know where that is in particular. It's a god-awful path. Okay, so what is the version set file? Okay, the one that was referred to in the previous slide is version 4.4.0.xml. Okay, and so this is an XML file. There's an XML throat clearing in these first couple of lines. And then G versions is the opening tag. /G versions is the closing tag. And then there's a, what do we got here? We have attributes to this tag, this G versions element, the file, without path, and the date the file was created. And there's also a description field here. These are update releases, meaning that they are just periodic refresh of the code, not for any particular purpose or with any particular modification other than the normal progress since the last update release. Okay, so and these are all the packages: Jana, Haldy Recon, Haldy Sim. You see, I had to change it. Last time, Alex noticed that we were talking about Sim Recon. You recall, for the old timers. So that's I had to change the slide. Dang it. Haldy Recon, Haldy Sim, HDDS, linear algebra pack. Live, Xerxes for parsing XML, root, CCDB, the calibration constants database, and then EVIO, which is the format of the raw data, RCDB, run conditions database. This is where we record, the magnet current online. Geant 4 is new version of Geant. HD Geant 4 is our implementation of the Geant 4 toolkit. HD utilities is just miscellaneous GlueX MC wrapper. This allows you to do Monte Carlo with including up to a web interface on the grid even. GlueX root analysis, this helps you with the root trees, the further processing when you start from the root trees that I mentioned. Previous slide, amp tools for amplitude analysis, partial wave analysis, AKA is an AKA. And then these SQLite packages to support SQLite, which is another form of the database. So I won't say too much about all the structure, but all of these have a version, okay? And some of them have this dir tag. The dir tag is really to disambiguate the cases where, for example, for GlueX root analysis, we may have this version 1.1.0, but this guy needs to be built against Hall D Recon. And this is the version that was built against Hall D Recon 4.3.0. There exists another one on the disk, version 1.1.0, which is built against some other Hall D Recon. So when Hall D Recon changes, we need to rebuild GlueX root analysis, and we'd like to have both available. So this dir tag is a little text string that gets tagged onto the directory name. That's the name dir tag, to disambiguate the parent, the prerequisite or dependent package that this was built against. So you can have both on the disk at the same time. Okay, so if you invoke GXM, that defines a lot of environment variables, and careful people who were here last time will notice how much the environment has changed since last time. There's big differences, right? No, it's basically the same. But this is the modern. This was off of 4.4.0 actually. And so all of these environments get defined, environment variables get defined, whether it's bash or C shell. And what was I going to say? They all get defined. And none of these environment variables were present before the GXM was invoked, with the exception of the path type variables, which have been extended. Okay, and so there's these, and then there's also these. And there's these, and notice we've only gotten to J's so far. There's these, the LD library path is very complicated. And all the way down to this. So it's a lot of environment to set up. And, the script is there to help you navigate that. There are other ways to do it. You can do this by hand, of course. But, God help you, right? I can't remember how to do any particular piece of this. I just have put it into the scripts, so the scripts will remember it for me, kind of thing. And then with the proper dependencies, one environment variable versus the other, so on and so forth. So it's recommended that you use the GXM method to set up your environment. Okay, so then at this point we can run the software. HD root is our sort of workhorse package to do reconstruction. One that takes the raw data in and produces the REST files coming out. And if you type hdroot to command line after invoking GXN, you will get the usage message, which means that your shell now knows where the program is. It knows where all the shared libraries are that have to be included. If you can get the usage message, right, the thing loaded. All the libraries that it needs, the root libraries, etc. System libraries have all been found and loaded at this particular runtime. So this is the help message is a big nothing as far as doing work, but it's huge in terms of whether you have your environment right to do all these things. Okay. So I won't talk about. I'm going to stop here as far as how to run HDRoot. Yeah, you can read the help message and kind of on your own. Okay. So GlueX mboot. Summarize. It defines this GXM command. This command itself sets up the environment according to a version set file, a version.xml. It also defines something called gxclean. And what gxclean tries to do is reverse the steps done by GXM. So I know what GXM did, so I can reverse it. That's not a bulletproof. It's clean is kind of overpromising, because anyone can do anything to their environment at any time, right? And I'm only reversing things from the point of view of someone who went forward with GXM. And I'm going right back along the same path. If you do something else, then you might introduce hysteresis in that process. Okay? But pretty much if you stick with these two, you're good to go. You wouldn't want to go through this cycle 1,000 times in one shell, and trust that everything went forward and back exactly the same. But generally, it works pretty well for the straightforward application. So this will get rid of everything in your environment, and you won't have anything left over the next time you set it up. Okay, so in fact, GXM invokes gxclean under the hood. It's the first thing it does. So it tries to reverse whatever you might have done before. Okay, it defines this build scripts environment variable. Remember that this was the environment variable where this thing was living in the first place. Back on the first slide, when I first talked about that, I had a long path. That was build scripts. It puts build scripts in your path so you can execute things directly. Any script that's in here can be executed, and we'll see an example of that in a second. And this thing, again, does not set up the environment. It's this thing that sets up the environment. Okay? All right, so the intermediate scenario. This is where you want to do a custom data analysis, where you have certain kinds of customizations that are anticipated by the software system, i.e. Plugins that you make yourself or that you got from somebody else or things like that, or particular root macros that you're running off of the root trees, things like that. And I'm not going to talk about any of that. Okay. The advanced scenario, for lack of a better word, is that you want to develop new features or debug old problems in the existing software. So in the build of all of these packages, you want to change a code and rebuild it, okay, with your own code, usually C++ in most of these cases. Okay, and so there's a canned script coming off of build scripts. This is actually going to be in your path now because I put build scripts in your path, but I put it in here for emphasis. So you can go to some random directory, make a random directory in the random directory, cd into the, this is doubly random by this time, cd into your custom directory. You can do a gxclean, for insurance, and then run this guy. Okay, so this will start with the current default version set, whatever that may be. It defines local custom versions of these 5 packages: HTTPS, Holiday Recon, Holiday Sim, HTTP4, GlueX root analysis, and builds them, compiles them, links them. It also creates setup scripts to use after everything is done. In this case, they'll be in custom. They'll say setup.gluex.csh, setup underscore gluex.sh, and so you have a bash and a tcsh version of the setup scripts, and these will have the location of the built versions of these packages hardwired into them. In particular, the version XML that gets created in this process will be referenced with a full path in both of these scripts. Okay. So you run this thing. Okay, so I'm on the iFarm. I'm in the directory custom. I say my hald build underscore JLab. Minus N6 says use 6 threads to do this. There's a help message from my hald JLab. My hald build JLab minus H, of course. Oh, there it is. It's documented right there. And to explain the small number of arguments that are possible. Okay, so the first thing it does is it grabs the default and it creates the default XML and creates a local XML called version.xml. Okay, and this looks the same as the default one from the system, except for you'll notice in this particular on this page, Haldi Recon, Haldi Sim, HES, those are 3 of the 5 packages that we're building custom. Okay, those do not have version numbers. Those have home directories defined. No version, but with a home. So this says that HDDS should come from this directory, and the version XML tells you to use the one that I'm actually just about to build. Okay, and never mind what version is in there. Just use that one. Okay, and then there are some things elided, but also I guess the ones that aren't shown that have home attributes are again HDGeon4 and GlueX root analysis. Okay, so the 5 packages. Okay, and so so it types that out the screen. It says what it's going to build: 1, 2, 3, 4, 5 packages. Is that okay? Of course it is. And then it in turn clones the packages in the proper order. And this ... refers to the building procedure. ... Okay. This is where you hear Benny swearing in his office. No, there's no need to swear because this will go like that. Just like that.
As a comment,
Benny would never swear. If he uses, he doesn't want to use it though, of course.
isn't that one of the lines you changed from last time? That you in fact use Git now?
No, it was Git last time.
It
was Git. We went to Git in 2015.
Yeah, no.
Before you were born. What?
Right.
That's not what I meant.
Oh, sorry.
The old installation packages was not used. It was copied down as a tar file and opened so that not used.
Right.
Update the code.
Well, yes and no. What happens is that if HDDS had a version number, instead of a home,
Yeah.
it would use that version number, find the tar file, unpack it, just like you said. Okay, but because it has a home, now it's going to go to Git to get it. Okay, the home implies give me a repository rather than a tar file and get the source from there. The version implies get the tar file. But the version is all you need because we know where it is on Git. Blah, blah, blah. It gets automatically generated. Blah, blah.
So is Jana is going to be built under this directory, or is going to use?
For this run of my Haldi build, I'm going to build these 5 packages, and Jana's not among them. Okay, but I need to have Jana defined because I need to build these things against a version of Jana. Jana here has a version, okay, and a directory tag, actually. So the build system knows where that will sit on the disk if you're a JLab. But, we're assuming you're a JLab. Okay, so it will not, this specialized the my type thing says stuff that people want to build on their own. Okay. And I do have to know where Janet is, and no, I'm not going to build it. Okay, so here's HD Recon being cloned, and then it has its own set of 3 dots, and so on and so forth. 3 dots, 3 dots, 3 dots for the other 3 packages. Okay, so when I'm done, this is literally off the screen. In this directory, I do an ls, and I see 5 directories. GlueX root analysis, Holiday Recon, Holiday Sim, HDDS, and HGN4. I see 2 setup files. These are real files, gluex.csh and setupgluex.sh, and I see 1 XML file, the contents of which I showed most of in previous slides. Okay, so this serves as a document as well of how you build things. Okay, in a sense. The home doesn't give you much information. It was cloned and you took the master branch at that point. So that part of it is not well documented, but everything else is for these guys. Okay.
Can you use GXN with this version XML?
Yes, you can. In fact, these setup scripts, I don't need them anymore because I can just say GXM this guy. You just got to remember where it is. The fact that these setup scripts actually go 1 level below GXM and invoke this in a hardwired way with a hardwired path. But this particular incarnation of this script was written before I had GXM, actually. So it actually exposes the inside, which is a bit confusing, but, I'm sorry. I'm so sorry. Good question. Okay, so switching gears, computing resources. Back in 2016, that's probably after you were born. So,
After everybody was born.
Sorry. Never mind. I didn't hear it. I'm not laughing because it wasn't funny. I just didn't hear what you said anyway. So there's more information on these resources, but there were 2 things which I copied and updated with numbers from yesterday. The work disk, okay, large files, personal builds, actually CCDB SQLite files, which I haven't explained what that means, but they should go on the work disk. The path is work call D. Right now we have 173 terabytes, and it's a traditional DFS RAID. So it sometimes gets bandwidth challenged these days since the entire lab is using the same file server, but nothing ever gets deleted unless we delete it from this disk. So something you put there today will be there tomorrow and the next week, unless you delete it. Okay, so MSS is a directory tree. This is a front-end representation of the tape library, so there are a bunch of little, what they're called, stub files, I guess. So for every file that's in the tape library, there is a stub file somewhere in the directory tree under MSS. Okay, so that's, so you search the tape library the way you search through a directory listing. And you refer to these stub files when you give a command to the tape software, which file you want to get or where you want to put a particular file on tape. Cache is a actual file realization of MSS, so the directory structure you see in MSS is the lowest order in 1-to-1 correspondence with the directory structure you see under cache. Okay, so if you want something off of tape, you ask for it and it shows up on cache. Okay, the directory of the stub file will correspond exactly to the directory under /cache rather than /MSS as the top level directory.
Mark, the system is smart enough that if something is already on cache, I request it from MSS, it will recognize that, or? Or will it just load the tape and overwrite it again?
I think it'll.
The answer is yes.
I think it'll fail. Yeah. Okay. The other thing about this, which is a bit confusing, is that it's what they call write-through cache. In that, if I take a file that's never been on tape, okay, and I stick it in the cache tree, then after some period of time, it will get copied to tape. Okay, and the location in the MSS tree is, of course, unambiguous because it's correspondence with a /cache. There are exceptions to that. The time scale for that happening is usually a couple weeks, but that can change. It's a little bit complicated. The link on the last slide that points to Computer Center or the SciComp documentation pages has an explanation of how all of that works. So I won't go through the details here. I won't remember all the details anyway. Okay, volatile, you can think of this as the scratch disk. It's network mounted. We have 30 terabytes guaranteed. We can actually run over our quota up to 60. Old files get deleted to make space for new. So if you put a file there today, it's probably going to be there tomorrow and probably the day after that for maybe a couple of weeks. But it depends on how much people are using it. It deletes old files first to make space for new ones. It always has space for new ones. Never runs out of space. Of course.
First in, first out type of thing?
Yes. First in, last out. No, first in, last out. What do I want to say?
First in, first out.
First in, first out. Yeah.
But
that.
it depends on the last time they've been used. So if you continue using them for something, then I think they get flagged somehow that they're
Like last modified or?
House drive.
Just read.
I think it's by modification date, actually.
is it by modification?
But you should double check me on that. It used to be modification. I had an argument about that. Yeah.
Touch them all every night.
I expressed concern with that thing several years ago. So we had to check to make sure I'm still speaking the truth on that.
A couple minutes left, Mark.
Okay, yeah. I think I'm. Yeah, this is the last slide. Okay. Offline software wiki page. One of the most maligned pages in the collaboration. It's been rewritten many times to confront criticisms, and yet it continues to attract criticism.
Only because everybody's reading it.
Yeah,
That's right.
Okay. But anyway, I'll stand by the statement. It's your main source of documentation. This is what I was just talking about, the scientific computing documentation site. That's scicomp.glad.org docs. And there's actually a lot of stuff there. Not all as hidden as one might have imagined. Okay, email list. The main list is halldyoffline@jlab.org. You can go here for information on the list to subscribe, get access to the archive. So announcements, software, news, information, and discussion. So that's fine. We went for many years just using this. So about 3 or 4 years ago, we introduced this GlueX software at Google Groups. This is referred to as a GlueX help forum. GlueX software forum, Google. Okay, so here you ask the questions. The idea is that you may not want to ask your dumb question, on the announcement list that everybody sees. Okay, so here you say, something's not working, and this doesn't really make sense to me, and so on and so forth, that kind of thing. You feel free. Most of the experts are logged into that. Response time is pretty fast. If you ask the question that doesn't get responded to right away, it's usually because you went over the heads of the experts, actually. too good of a question. And then the last place that we've added is this Slack thing, which many of you probably have heard of it. So, but these are a set of chat rooms and the ability to send DMs to your colleagues. You want to use your JLab email address when you sign in to create access to the workspace, which is the Jefferson Lab workspace, which has this URL, jlab12gev.slack.com. Okay, and then there are many channels, of course, within this workspace. The one that's probably most relevant for us is Town Hall D. And Slack is for the questions that are even dumber than the ones that you might ask on the help list. Like, has anyone seen my keys, kind of thing, whatever. So, but it's useful because it's very informal and
Yeah, physics questions too, right? Yeah.
Well, yeah, there's no rules. So there's this hierarchy and of formality, let's say, and so we have this, and that's it.
Okay, thanks, Mark.
I have one question about the environment. Is Swift integrated into the GlueX environment?
Swift,
No. So I have to source.
This is kind of underneath Swift. In other words, this is a way to tell Swift how to set up your environment. But when you submit your script, telling Swift to do this, this should include a setup of the environment, and this would be part of that instruction.
Yeah, so it has to trace back to the GlueX, right?
Only as far as you have the traceback. You're submitting the script that you want Swift to execute, and it'll do whatever you say. It doesn't. Swift itself doesn't have knowledge. That's the next level of abstraction.
Thank you.
At JLab, Swift is located at site bin, and I think it's part of the standard logon script added to your path. At least I never remember adding Swift in.
Everybody gets Swift for free.
Yeah, exactly. As long as you're at JLab.
Yes.
Next, I found where to source it because I had problems submitting analysis before. There was a sequence of sourcing that had to be done.
If site bin needs to be in your path, then all Swift.
I should have my CSHRC then.
Okay, Con?
Yeah. One question. So this GXenv is really useful, it seems. So, but it only works in JLab, right?
Well, no. Okay, so there's this GlueX install package that we've had in the past, which builds everything from scratch, and it has its own directory structure, which is actually kind of similar. So that now didn't until maybe 2 or 3 months ago, or relatively recently, will write scripts in your GlueX top to support GXM.
Oh, it will now. Okay.
It will support GXM. It'll support GXM. It's different than this one because it's different. But since it knows, GlueX install knows what it's building starting from the current directory, and it knows the current directory, it knows where everything is. Okay, so you can implement GXM there as well. That's relatively new.
It'd be really nice to have a document for how to deploy the GlueX software stack. Remote machines.
Yeah.
I guess you got to have a system first, and then you can document it.
Oh, no, I mean, we've had a system, so.
There is a system to install things from scratch.
Yeah, that is documented. That is documented. This GXM in that system is not documented. In fact, I was just adding a few details to that documentation and broke the HTML tree, screwed up your on Friday. So I know someone's looking at it.
So maybe it just needs to be refreshed then.
Yeah, exactly.
About the GlueX script, because I tried to source on Friday and it gave me 2 errors, like the basic GlueX environment.
Okay. Well, you should swear at me on Slack.
Yeah, I'll start doing something. That's a good.
No, but that kind of thing that's a good one for the software help list.
Yeah.
You know, because we don't want to tell everybody that. Oh, yeah. On the other hand, your problem may be common.
Yeah,
to a lot of people.
I suspect it is common.
Right, so then it's a really good candidate for the software help for the Google group. All right.
So I have one question, Mark. So using this my holiday build JLab, can I build only one package or?
Oh yeah, I should have mentioned that. The last set of arguments are you name the packages that you want. So you can name up to the five. If you don't name any, then of course you get all five, but you can name any combination of the five at the end. Yes.
Okay, we should probably move on to the next talk. Thanks, Mark, again.
Thanks, Mark.
Next, Alex is going to tell us about more specific use cases.